All right, welcome back. I'm looking at question 38 now. And so it says the mean credit card debt for a US household is $7,115. Okay. So they're talking there about the population. And so we're going to label that value as mu. It's the population mean. And it has a standard deviation of $2,160. Okay, again, it's still referring to the population, so we're going to label that sigma. Now, this mean is such a large value because of a few deeply indebted households. So that's telling us that either there are some outliers in the population or that perhaps the population is skewed. Okay? Now, if a random sample of 50 US households is selected, okay, so we know that's our sample size, label it N, what is the approximate probability that the mean credit card debt for the sample exceeds $7,500? Okay, so the key words there in the question, it's asking about a probability. Okay, it's the mean of the sample exceeds 7,500. Okay, so let's write that symbolically. Okay, we use the letter P for probability. The mean of a sample would be X bar. Exceeds would be the greater than sign. And of course, $7,500 is just a number. Okay. So this is a question about the sample mean. And so to answer this question, we cannot use the population distribution, which has already been described in the problem, but we have to figure out the sampling distribution, right? What do the values of X bar look like when we take repeated samples from this population? Okay. So the sampling distribution of X bar. Okay. So let's first start with the shape. Okay. Now, even though the population, we said, may have outliers or may be skewed, the sampling distribution should be approximately normal. Okay. And that's because of the central limit theorem. Okay. Our sample size hits at least 30, and so by the time your sample is that big, when you look at multiple sample means or X bar values, plotted out on a dot plot, they're going to have an approximately normal shape. Okay. The center, now I'm just stealing this formula from the formula sheet. The mean of the sample means is just equal to the population mean, which we know is 7,115. Okay. And the spread, again, this is a formula that's on your formula sheet. The standard deviation of the sample means is equal to the population standard deviation divided by root n. So that'll be 2,160 divided by the square root of 50, which comes out to roughly 305. Okay. So to calculate this probability, we're going to use a normal distribution, and we're going to shade the area to the right of 7,500. Okay. So let's start with a number line and a bell curve. Okay. So the mean or center of the sampling distribution is 7,115, and then we're going to use an increment of 305 to get everything else. So just do this really quickly. So I added the value 305 3 consecutive times, and then I subtracted it 3 consecutive times. Okay. All right, so the area of interest is going to start at 7,500, and we're going to shade the area to the right because it's a greater than sign. Now, the traditional way of figuring out that area is to calculate a z-score, look that z-score up in the table. That's before there was technology. Okay, but since we've got technology, let's use it to our advantage. Okay, the TI calculators have a command called normal CDF. Okay, and the inputs are the lower bound, the upper bound, the mean, and the standard deviation. Okay, so if you know those 4 things, you can find the area of any interval under a normal curve. Okay. So let me pull up my calculator now, and we're going to press second vars, and there's the command normal CDF. Okay. Now the first thing I need to input is the lower bound, so my shading starts at 7,500, and then it extends all the way to the right, so that's all the way to infinity. Okay. Now, there's no button on the calculator for infinity, so just choose a really, really big number. I'll just type a bunch of 9s. Okay. And then the next input is the mean. So we can see from our drawing, the mean is 7,115. And then the standard deviation, which remember I'm covering it up, but it was 305, right? That's the increment we used to create this sketch. Okay, close the parentheses. I think I did that right. And, oh, nope, syntax error. So let's go back and just hit enter. Nope, still a syntax error. Geez. Yeah, maybe just click that. There we go. So 0.1034. Okay. So if we look at our answer choices, oh, look at the first one, 0.1038. It's pretty close to our answer. I'd say that's it.